Welcome to the GOTO podcast. In this episode, Francesco Cesarini, founder and technical director at Erlang Solutions, discusses how he's used Erlang to solve problems at scale for more than 30 years. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Maybe even before I introduce you, we're using Riverside here. Is Riverside running on Erlang?
Hi there, not that I'm aware of, but I think there are quite a few streaming platforms and frameworks written in Erlang and Elixir, which can be used. I think we were working with Uvu, which was number 2 after Skype many years ago. All of the connections of the video streaming was being set up by Erlang. Cisco and Ericsson's video systems are all Erlang based. There is a Membrane, which is a video streaming framework which can be integrated. Is written in Elixir, and there are many others out there as well. So at the end of the day, I think video streaming, all you're doing is instead of connecting 2 phone calls, you're connecting a few video streams. So the business logic is very much the same.
That makes sense. Yeah. Before we get too far here, may I ask you to introduce yourself?
So I'm Francesco Cesarini, the founder and technical director at Erlang Solutions. I've been working with Erlang back since the 90s, the mid 90s. And we're very fortunate to have seen a programming language become an ecosystem of languages. If you would have asked me back in '95, if I was still working with Erlang in 2022, I would have said probably not. But I still am, and we're still kind of solving problems which were relevant then and are probably even more relevant today.
Welcome to our little unscripted series here. You said 95, mid-90s. Erlang is way older than that, isn't it?
Well, Erlang, the language itself, they started working on it in the late 80s. What the computer science laboratory was trying to do is figure out, how do we program the next generation of telecom switches? And it took them a few years. I think the first real fast virtual machine was ready in 91. And then 1992, they started developing the first product, which was then released in 94. So I'd say 94, 95, is when it was ready to be used outside of the lab and started becoming mainstream and started being used within some of the major projects within Ericsson. Okay,
I was actually back in the start 80s, but I was wrong. Is it coincidence that Erlang, I suppose this has something to do with Ericsson language or whatever, is it pure coincidence that there was a Danish professor, I think his name was Agne Krarup Erlang or something like that, who invented some queuing theory? Is there a connection here?
There definitely is a connection. Actually, Erlang was named after Agne Krarup Erlang, the Danish mathematician. So he was, for those of you who don't know him, he was he basically was a founder of kind of teletheory, telephony theory. He created the Erlang formula, which is the formula used to figure out if all of the lines within a particular call center are busy at any point in time. But as Ericsson management were paying for the development of Erlang, they made Ericsson management believe that it was actually named after Ericsson. So Erlang. So management thinks it was named after Ericsson. Those on the inside know it was named after the mathematician.
Interesting. So Erlang, Ericsson language, that's more like marketing. How does it work? Actually, what are the deep secrets the language?
Well, Erlang itself is just a programming language. I think there are three things which when put together give you the secret sauce. So one of them is the Beam virtual machine. So it's a virtual machine which is highly optimized for a large-scale concurrency. It's being optimized to scale on multiple architectures. And just recently, actually, they've added the just-in-time, the JIT compiler. So that's one third, I think, of the power. The other third is something we called OTP. OTP is a middleware and a way of abstracting from the concurrency models, which increase the programmer productivity. But also on top of increasing the programmer productivity, they hide all of the tricky parts of dealing with full tolerance and with concurrency. So by using OTP and by using the programming principles, your systems will scale and by default be resilient. And then the third is, I would not even say Erlang itself, but the semantics of the programming language, of the Erlang programming language. And these are semantics which most languages running on the Beam today, so including Elixir, by default inherit. And put those three together, that's when you get the real power of the ecosystem. And just to quote Joe Armstrong, you can copy the libraries, which is what's happened with OTP on the JVM or in .NET and in many other. I've seen it being copied in Java and many other programming language ecosystems. But so you can copy the libraries, but if it doesn't run on the Beam, you cannot emulate the semantics. So it's the three basically put together which give you the full power. The semantics of the language have a very tight one-to-one mapping with the operations of the virtual machine. And then OTP is built on top of that to facilitate and hide complexity from the programmer.
Okay, so the idea that Elixir is the new generation of Erlang, that's actually not true. It's another language running on the same VM.
That is correct. Well, actually, Elixir compiles to Erlang, and that was a choice I think José Valin did consciously, so as to be able to utilize all of the tooling and and libraries which exist in the Erlang ecosystem when he went in and created Elixir. And so I would almost call Elixir a new version of Erlang with a slightly different syntax, different tooling, and a different development approach to what we are used to in the Erlang world. And by doing this, by changing the tooling, by improving the tooling, by providing frameworks which were specific to certain types of problem, he opened kind of the power of Erlang to a wide range of developers, for which it wouldn't have been accessible otherwise.
Yeah, that's true, because I have a feeling that that Elixir is, as you say, it's addressing a complete new audience as compared to, let's call it, the original Erlang community. Yeah, correct.
Absolutely, you're perfectly right there, and he did it. Yeah, he did a fantastic job. I mean, his goal. If I always ask programming languages inventors, why did you invent language X, Y, or Z? And when I asked José that question, his answer was, I wanted to open up, the power of Erlang and the Erlang virtual machine, so the Beam, to a much larger, a wider range of programmers, and more specifically, I think the first time asking that question, his focus was web developers. So how do I bring the power of Erlang to the web development world? And web developers and Erlang developers, it's telecom versus web. It's two completely different problems we were solving. And these two different problems require completely different approaches. So they require different toolings, different libraries, different frameworks. So and that also explains why our attempts of trying to bring Erlang to the web, failed, back in the mid 2000s. There were a lot of web frameworks written in Erlang, Erlang Web. I think there was Cowboy, Yours, web servers, but none of them addressed the requirements of the web developers at the time. Instead, what they did is they addressed the requirements of those developing telco infrastructure.
How does the fault tolerance actually work? The OTP?
More than OTP, I think the fault tolerance it's a very simple notion that you've got processes, and processes do not share state. They do not share memory. And so what that means is you can have many processes running at the same time. And if something goes wrong in a process, so if there's a bug in the code, the process is running, or the data gets corrupted, you just terminate that particular process. And by terminating that process, all the other processes around it, which are not dependent on it, are not affected. So imagine that you've got thousands of phone calls going through your system. Each phone call is a process. And if something goes wrong with one particular phone call, you lose that phone call, you lose that connection. The other phone calls aren't affected. And so that's a core principle of processes, and processes not sharing state. We then take these processes and we group them into what we call supervision trees. So a supervision tree is basically a process whose only task is to supervise other processes. And when supervising these other processes, if a process fails, the supervisor is immediately notified of it and is able to react. And it can decide how to go in and actually deal with that failure. Could we try to restart that process and reconnect that phone call, or do we just ignore it? Or are all of the other processes somehow maybe it was a group call and it was the host process which terminated, and it goes in and decides maybe we should terminate all of the other connections and then restart them. And by doing that, what you're actually doing is you're removing failure and error handling from the hands of the programmer, and you're generalizing it. So you might have heard the whole let it crash approach. And that's what we refer to in the Erlang world. When we let processes crash, we don't mean that we ignore failure or we encourage it. It's just that we handle these errors in a slightly different way. And by handling them in a more generic way, that's how we create this full tolerance. We isolate failure, and then we escalate it only when necessary, and we control it. We control it in a central way, in a generic way, and this greatly simplifies the code base. Comparisons with Erlang and C++ code, where they went in and implemented the same problem in Erlang and C++, resulted in the C++ code base, about 25% of the code base was error handling and fault tolerance. The equivalent in the Erlang code base was about 1%. So there's a huge difference in the code base. So just by going down the Erlang route, your system becomes fault tolerant, but you also reduce your code base by around 25%. I don't know if that makes sense, but...
Well, it does. It's like that's like exception handling is just being propagated out to the bookkeeper.
That is correct. Yeah, exactly. So we just pushed all of the exception handling to the supervisor, and the supervisor handles it in a standardized way. Instead of letting the programmer deal with exception, because again, if you have an exception, you don't know why you got that exception. How do you deal with it? You don't know how to deal with it, because if you knew, it wouldn't be there in the first place. So by generalizing how exception handling is managed, you basically get rid of exceptions, or they could become a very, very rare occurrence.
Akka, like Akka.net or whatever frameworks there are.
Yes.
They're very much inspired by this.
That is correct, yes.
I think they come directly out of the Erlang world even, yeah.
That is correct. So Jonas Bonner actually started implementing akka when he was working as a consultant on a customer project, and the customer wouldn't allow him to use Erlang to solve a particular problem. So he got so frustrated that he took OTP and the whole error handling in OTP and started porting it to the JVM. Now, and I think he did an amazing job at bringing it to the JVM. It's not for the faint of heart, because the JVM wasn't built for, the JVM was built for parallelism. And what he did is he bought lightweight concurrency and green threads, which used to exist in Java, but got removed early on to the JVM. And it's almost like when I was reading the original Java white paper, I had a sense of deja vu, which was a virtual machine and a concurrency model, built-in memory management, and a garbage collector. So this was a JVM, and I was working on the Erlang virtual machine at the time. But I think that there's still a big difference, between the Java virtual machine and the Beam today, because to bring akka, to the JVM, Jonas actually had to emulate a lot of the semantics and a lot of the functionality which exists in the Beam, which the Beam is highly optimized for, which doesn't exist in the JVM.
Yeah. Yes. And all the protection.
Exactly.
All the protection spaces around processes. Yeah. That needs to be replicated into a thread model instead.
Exactly. So he had to create all of that layer. And even there, I think there's he wasn't able to fully create, or emulate the semantics, because the akka actors have to yield, and so you're basically putting that in the hands of the programmers. So versus Erlang, where your processes get given a certain number of operations they're allowed to execute, after which they automatically get suspended, and the next process gets to execute. So you run the risk of an actor in akka starving all of the other processes, all of the other actors, and that's not a risk you have on the Beam, because again they've removed that from the hands of the programmer. The programmer doesn't even know that how the processes are actually being scheduled and managed. And they shouldn't know. They should just program, thinking concurrently, and then the rest is all abstracted away from them.
Yeah, so now it becomes really nerdy and really interesting, because these processes in the Beam, are they really processes supported by the hardware, by the CPU? Or is it some middle thing between a real process and a thread?
Yes. So what happens is when you start the Beam, it will start a scheduler in a separate thread for every core. So assume you're running on a quad-core machine. The Beam will start 4 threads. Each thread will run a scheduler. And each scheduler, will have its fair share of processes. And so assuming you're running, you've got 400 processes, each schedule will have about 100 processes each. And then, there's migration logic, which ensures that, the different schedulers remain fairly balanced. So, processes might be migrated from one scheduler to another. So from one thread to another, if most of the threads on a particular, in a particular scheduler terminate.
There used to be, I don't know if it still exists, but there used to be some project, some library framework called Lua. Does that still exist? That allowed you to act. This is something for the audience here. That actually back then, at least, allowed you to run Erlang on an iPhone. Does that still exist?
So yes, they still exist. It never really made it into production. I'm not aware of any Erlang or Elixir development on iPhones. I think that's a subset which was that's basically part of the market, which I think was handled very well by these technologies. And again, for the same reason as to why we failed, to get Erlang into the web development space. At least us historically, we were all server-side backend systems. Those are the types of problems we solved. So even though you could develop Erlang on the phones, the types of toolings and frameworks you needed were very, very different.
I guess it goes very much against the idea of having a phone, but that's another discussion. It's like a client and not a server.
That's correct. But we're seeing a lot happening now for Elixir, making its way into an embedded space through nerves. There are graphical packages which can run on handheld computers, and so and also to the point where I think we were running Erlang and controlling the CAN bus with Erlang in cars probably 15 years ago. Almost 15 years ago. But it's really now making it mainstream, becoming mainstream now, where we're collecting more and more data in the cars themselves, and in the cars, and in all of the IoT devices themselves. And it's not becoming feasible anymore to actually go out and push this data, to the edge network and to the cloud, because of the large volumes of it. So you actually start analyzing it in the devices themselves. Or, in some cases also in the edge network, where feasible. So we're seeing Erlang and Elixir being used in those spaces more and more these days. And I think with the work which has been done on the JIT compiler, which has had huge performance increases, and the work which has happened with numerical Elixir, which is then enabling the whole Axon framework, which is very similar to PyTorch. I suspect you'll be seeing machine learning now moving onto the devices, onto the embedded devices, in cars, in IoT devices, and to a certain degree also in the radio-based stations and the edge networks. So I think it's still early days, but I think there are a lot of exciting things happening in that space, and all of the components are being put in place for it to become for it to become viable and an alternative approach and technology for machine learning.
How much is the Erlang universe actually evolving right now? If we could isolate plain Erlang from Elixir.
Very little, very, very little. So Erlang itself, at least the programming language, there are very few changes happening. Most of the work, I think, is done around the libraries, the frameworks, but also on the Beam virtual machine. That's where I think a lot of the effort is going in today.
Yeah.
But the language itself, Ericsson, who, whilst Erlang is open source, Ericsson is a benevolent dictator. They've always been very conservative about introducing new changes. For two reasons. A, they've got millions and millions of lines of code in production. So any known backwards compatible changes would have a huge impact on all the code they've got in production. But B, if they start pushing out new features, they need to support and maintain them. So they're very, very careful over what actually gets released. But a lot of the work and a lot of the focus is on really making the Beam scale on multi-core architectures, making it fast, making it lock-free. And we're seeing, with every release, all you need to do is actually go in and, in some cases you don't even need to recompile your Beam code. You just need to rerun it. In some cases you might have to recompile it. But, back in the days, we used to joke that, if your program wasn't fast enough, wait 15 months and then you buy a new computer is going to run twice as fast. Now, it will run faster the more cores you throw to the problem. But all you need to do these days is just wait for a new version of the Beam and recompile your Erlang code, and it's going to run faster.
Thank you. It's been fascinating talking about this, and I think we could go on all day.
Thanks for listening to this episode of the GoTo Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.